Hello students. In lesson number 3, metals and non-metals, let us move further. In the previous lecture, we have learned about the chemical properties of metals and non-metals, how metals are reacting with other materials. In one of the reactions, we have seen that when metal react with the salt of other metal, okay, one metal react with the salt of another metal, that reaction is a displacement reaction in which I have told you that a more reactive metal is able to displace the less reactive metal in the salt and making a new salt, and that less reactive metal will be released as a solid metal. So that in that we have talked about the reactivity of a metal. So what actually the reactivity is? So let us learn the reactivity of metal. We have seen that in the definition of metal, that metals are the elements which have in which the atoms of that elements have tendency to give electron. Okay, so metals have the tendency to give electrons. So each and every atom, so atoms of every elements of metal have the tendency to lose electron. But which the tendency to give electron is different in different elements. So it depends on the number of electron in the outermost orbit, that how the atom will give electron. Some atoms, so this tendency of giving electrons depending on how strongly that electron is attached with the nucleus, right? There is the attraction between the positive nucleus and the electrons around it. So if the electrons are bound strongly, then losing of electron will be quite tough. But if the electron, that attraction is less, the electron is less bound with the nucleus, then that electron will be very easily lost by the atom. So wherever in every metal atoms, they have the tendency to give electrons, but how easily the atom can give electron, that decides the reactivity. So reactivity is nothing but how readily an atom lose electron, an atom of metal lose electron. Every atom of every metal will give electron, but some of the metals is very ready to, very eager to give electron, and that is because the attraction of the outermost electron with the nucleus is very less. Okay? So if the attraction is less, it will readily give the electron. So the atom which is very eager to give electron will be more reactive. Okay? So reactivity is decided by that how readily an atom is giving the electron. So and this giving this process of giving electron, that means the reactivity is decided by some of the by three methods. So it is decided by the reaction of metal with acid, with water, and the third method is displacement reaction. Okay, if the metal can displace the other metal, then it is said that that particular metal is more reactive to other, because that if it is more reactive, then and then only it will able to displace the other metal. If it is less reactive, it will not displace the other metal atom in the salt. So mainly by the displacement reaction, the reactivity series is written like this. The highest reactive metal is potassium, then sodium and calcium. So these three are called the high reactive metals. Then after, so this series represents the reactivity of metal in decreasing order. Okay, so highest potassium, then sodium, then calcium, then magnesium, aluminium, zinc, iron. Okay, so magnesium is more reactive than aluminium, aluminium is more reactive than zinc, zinc is more reactive than iron, then lead, Pb, that is lead. Then there is a hydrogen, and hydrogen is actually non-metal, but hydrogen have one electron in the outermost orbit. So hydrogen also have the tendency to give electron. Okay. So the tendency of giving electron is the metallic character. Okay. So hydrogen is, in that way, hydrogen is showing the metallic character. All the properties of hydrogen is as a non-metals. So in how readily hydrogen is giving electron, that is comparatively lesser than the iron, lead, and greater than the copper. So hydrogen is more reactive than the copper, then Hg, that is mercury, then silver, and Au, that means gold. So this iron, this lead, hydrogen, copper is the lesser reactive materials, metals. Then mercury, silver, and gold are the negligible reactive. Okay, the reactivity of this three is very much less. So negligible reactivity. Okay, so this is how from going top to bottom, the reactivity decreases. It means that reactivity, sense that the tendency of giving electron decreases from potassium to gold. Okay? So this was about the reactivity series. Now, the next is how the reaction of metal with non-metal. How metal react with non-metal. This can be understood as it is. See, metal have the tendency to give electron, okay, and making the positive ion. So in the outermost orbit of the atom of metal, having 1, 2, or 3 electron, okay, because every atom have the tendency to complete its octet, okay. So if in the outermost orbit there is 1, 2, and 3 electron, then that will be lost by the atom and it occupy the octet configuration. So by losing 1, 2, and 3 electron, they makes positive ion, which is called cations. And non-metal have tendency to take electrons. So if the atom of non-metal is having 5, 6 electron, okay. So by gaining the electron, the atom of non-metal will complete its octet configuration. Octet means 8 electrons. The orbit wants to complete 8 electrons. Okay. So if they have 5, 6, and 7 electrons, it will gain the electrons accordingly and making negative ions. Gaining of electron makes negative ion. So a negative ion is known as anions. So non-metals makes anions. So metals have tendency to give electron and non-metals have tendency to take electrons. So this will this two property of metal and non-metal, they what we can say, complements each other. Right? Let us understand this by taking the example of NaCl, where sodium is a metal and chlorine is non-metal. So how they both will react? Sodium, the atomic number of sodium is 11, so its electronic configuration will be 281. While chlorine has the atomic number of chlorine is 17, so its electronic configuration will be 287. In sodium, the outermost orbit have 1 electron, and in chlorine, the outermost orbit have 7 electrons. So sodium, to complete the octet configuration, sodium will lose this 1 electron. Okay? And chlorine needs 1 electron. So this thing is very much convenient for sodium and chlorine. So sodium 281, sodium atom will lose 1 electron and making sodium plus. And now sodium plus have 2, 8 configuration. Okay, so before sodium have 11 electrons, and after losing 1 electron, it is now having 10 electrons and 1 electron will be lost. This 1 electron will be added in chlorine atom. So chlorine having 287 configuration, 17 electron, and 1 electron will be added. So making negative ion, and now the configuration will be 288, total 18 electrons. So wherever sodium and chlorine come in contact with each other, they complements each other. That means sodium will give its 1 electron to chlorine, and both making complete configuration, and one becomes positive ion and another becomes negative ion. So this Overall, we can write this reaction as it is. Sodium, the outermost orbit electron are mainly responsible for the reaction. So only outermost are written. So this dot represents the one electron in the sodium atom, and chlorine has 7 electrons. So 1, 2, 3, 4, 5, 6, and 7 electron of chlorine. When these two react with each other, sodium will give its one electron to chlorine. So sodium becomes sodium plus. Now there is no electron in the outermost orbit, and one electron will be added in chlorine orbit. So 1, 2, 3, 4, 5, 6, 7, and 8 electron of chlorine is completed. Sodium becomes plus and chlorine becomes negative. And this positive negative, we know that positive negative attract each other. So there will be some force between this positive ion and negative ion, and that force is nothing but the strong electrostatic force of attraction between positive ion and negative ion. And this force, which was electrostatic force of attraction, held these two ions together, right? And that makes the NaCl molecule. So this is how the metals and non-metals are making the compounds by giving and taking. We can say that by exchanging of electron, right? So this is how the NaCl is formed. Further examples can be taken as a magnesium chloride molecule, which is also the same as the sodium chloride. Magnesium chloride, that is MgCl2. Magnesium has the atomic number 12, so its electronic configuration will be 282, while chlorine has the atomic number 70, whose electronic configuration is 287. Magnesium have 2 electrons in the outermost orbit, and chlorine has 7 electrons in the outermost orbit. So magnesium will tries to complete its octet by losing this 2 electron. Okay, instead of gaining 6, it is easier to lose this 2 electron to complete the orbit. So magnesium will lose 2 electron and making Mg plus 2. Okay, this plus 2 represents that 2 electron is lost. And now the electronic configuration is 2. And now, but chlorine needs only 1 electron to complete the orbit. So one atom of chlorine will gain 1 electron and another atom of chlorine will gain another 1 electron. Okay, so total 2 atoms will gain 1 electron each and making 2 chlorine negative ion. And each one's electronic configuration is 288. So ultimately we can write that magnesium 2 electron in the outermost orbit and chlorine have 7 electron in the outermost orbit gives magnesium plus 2 and 2 atom of chlorine gain 1. So chlorine outermost orbit electronic configuration will be like this: 1, 2, 3, 4, 5, 6, 7, and the eighth one is of magnesium. So this dot and cross are generally used to represent electron, and this different sign for point and cross that only represents the electrons from different atoms, nothing else. Okay, so MgCl2. So magnesium chloride chemical formula will become MgCl2. That which and why it is so? Because magnesium will give 2 electrons and 2 chlorine atom will gain 1 electron each and making magnesium chloride. Okay, so one magnesium positive atom will with this magnesium positive atom, 2 chlorine negative ions, sorry, magnesium ion, positive magnesium ion, 2 chlorine ions, negative ions will attract with magnesium by the electrostatic force. So by this manner, the metal and non-metal are reacting. Metal becomes the positive ion, non-metals become the negative ion, and this positive negative ion will be attracted and making the molecules. So the compounds made by this manner is known as the ionic compound. So simply the name itself is giving the compounds made by ions is called ionic compounds. But the definition can be written as the ionic compounds are the compounds formed by the transfer of electrons from metals to non-metal is known as ionic compounds. So this is the definition. By transfer of electron, one is giving and another one is taking the electron. So by transfer of electron from metals to non-metal, this compound is known as ionic compounds, and also it is known as electrovalent compounds. Now, what is the properties of this ionic compound? Some general properties can be listed as it is. The first one, the physical nature. Generally, the ionic compounds are solid and somewhat hard because why it is hard? Because there is a strong attraction force between positive and negative ions. So these compounds are hard but brittle. Okay, when applied force at some angles, then that solids can be broken into pieces. Okay, so they are brittle also. Melting and boiling point. Generally, the ionic compounds have high melting and boiling point because large amount of energy is needed to overcome to separate the ions, to melt it. To melt means to convert into liquid state, and to convert into liquid state, the ion should be separated. Okay, so to separate the ions, to overcome this attraction force, high energy, high heat energy is needed. So generally melting and boiling points are high for ionic compounds. Solubility. The ionic compounds are very much soluble in water, but they are soluble in organic solvents like kerosene, petrol, benzene. In this organic solvents, these are the organic compounds. So in these organic solvents, the ionic compounds are not soluble. Conduction of electricity. Generally, electricity. For the conduction of electricity, the solid form, they doesn't conduct electricity in solid state. Okay, if they are in solid form, they doesn't conduct electricity. But if this ionic compounds are soluble, made soluble in water, and if we make the solution, they conduct electricity in solution form. Because in solution, whenever these ionic compounds are added in water, water expands. That means if NaCl is added in water, water will dissociate Na plus and Cl minus. So every time the ionic compounds are dissociated, the positive and negative ion are separated by water. So by the dissociation process, the ions are separated. Okay? So whenever the two electrodes are dipped in the solution to make the to and the circuit is made, then positive ion will be attracted towards the negative electrode, and negative ion from the solution will be attracted toward positive electrode, like in the electrolysis process. And by this process, by the separation of positive and negative ion, the transfer of electrons is there, and we can say that the electricity is passing through the solution by the ions. But in solid state, the ions are strongly attached with each other. Okay, so there is a fixed space, fixed position for ions. Okay, they cannot be moved from that solid form. So in solid state, they doesn't conduct electricity, but in molten state, they conduct electricity, because in molten state, the ions are separate, so they can freely move. If the ions can move, they can transfer the electrons. It means that they can conduct the electricity. So this is the some of the very fundamental physical properties of ionic compounds. This is very important question to be asked in exam. So read up to this, and still if you have any doubt, you can ask me. Thank you.